You can combine various commands together into a script. This is extremely useful for automating tasks. I have tens of scripts in my home directory, which I use every day. Furthermore, in any project I'm working on, I typically create many more shell scripts. In this unit, we will see how we can create scripts, how we can pass arguments to them, and how we can process those arguments. Creating executable programs, scripts, with a shell is a piece of cake.
As an example, let us create a script to display the current time in Paris's time zone. First, I use the cat command in order to type in a file named Paris time. The first command I insert in this file is #bin/sh to denote that the file will be executed by the program named sh located in the directory bin. This is the UNIX shell. In computing, the character sequence # at the beginning of a script is usually called hashbang or shebang. Next, I use an environment variable called tz to set a time zone, Europe-Paris, in which the following command, date, will operate. As we saw earlier, the date command displays the current date and time. Using Ctrl-D, I end the commands I type into a file, Paris time, and the prompt returns. Now, if I execute this script with the shell entering sh Paris time, we get as output the current time in Paris, which is the Central European time. On the other hand, if I run the date command, we get the current local time, which in my case is the Eastern European time. To avoid executing a script through a shell command, we can change its file's permissions to make the script directly executable. To do that, we use the chmod command for change mode and pass the option +x, which stands for execution. In this way, chmod +x, Paris time, makes the file executable. Now, by entering /Paris time, the script is executed and displays the current time in Paris. Furthermore, in order to avoid the / specification in front of Paris time, we can modify the built-in variable path, which we examined earlier when we introduced variables. As you may remember, the path contains a colon-separated list with the locations of all directories where the shell looks up the commands we instruct it to execute. We modify it by appending the current directory, to the end of the path list without forgetting to add the colon separator. This allows us to directly execute scripts without specifying the current directory. By convention, personal executable files are placed in a directory named bin under a user's home directory so that users can put there their personal scripts and programs. To create a bin directory, we can run mkdir $home/bin and then add it to the path variable. For me, $home is /home/dds. Again, we append the location of our bin directory, home bin, to the path list, separating it from the previous path element with a colon. Since bin is now included in the path variable, all executable files under bin can be executed from any other directory omitting the path. As an example, I move Paris time to the bin directory and then go to the TMP directory. Running Paris time in TMP, we still get the time in Paris.
Command line arguments are passed to scripts through numbered variables.
I create a new script called anyTime that displays the current time of any part of the world. The variable $1 is the first argument passed to the script. Using the echo command, I first output the location stored in the $1 variable. Next, I set the time zone to $1 and run the date command. Now, by running anyTime specifying Europe-Amsterdam as an argument, we get the time in Europe-Amsterdam is, along with the current time in Amsterdam. As another example, I specify America-Los Angeles as an argument to display the time in sunny California. Similarly, with Europe Athens, I display the Athens time.
You can make your scripts modular, and you can also define new functions through the shell's function definition facility. In common with shell variables, functions are maintained during a shell's session. If you want to send some variables and functions for all your shell sessions, you can do that by setting them in a shell-specific initialization file, such as .bashrc for the bash shell.
Here, I create a function named showTime that converts a specified time from one time zone to another. A function is defined using a name for the function, followed by an opening and closing bracket, and then a set of commands, usually enclosed in curly brackets. In this example, I specify a set of local variables to use for naming the input arguments. The first local variable is tzin and stores the argument of the input time zone. Tzout is the second variable where the argument of the output time zone is stored. The last local variable I set is named time and stores the third argument, which is the time to convert. The function first echoes the input time zone, the specified time, and the output time zone. Then it sets tzout, the output time zone, to a variable named tz and runs the date command. At the same time, it passes to the date command a -date command line option, which contains the input time zone, tzin, and the time to convert. In this way, the date command receives the input time zone and the specified time through the date argument, converts it to the desired output time zone, and stores it in tz. Tz is then printed next to the output of the previous echo command. Having now defined the function showTime, I can use it to convert, for example, the time 11:45 from New York's time zone to India's. We see that when the time in New York is 11:45 in the morning, in India's Kolkata the time is 10:15 at night. That's correct. The time zone difference includes a half hour.
This concludes our Foundations unit on scripting. Stay with us.